Hello and welcome to my talk at ChefConf 2022. Let's hope this will be the last virtual ChefConf and that we can meet in person next year again. But for now, we will try to make the best out of it. While this talk has been pre-recorded, my future self will be available for questions as you are watching this, and I'm always on the chef communities, like if you have questions or feedback. So let's start. As someone who is all about technology, I don't want to spend too much time on introductions, but a short one is okay. My name is Thomas and I work as a consultant at TechRacer in Germany. We are a chef principal partner and have been working with our customers since 2016 to make chef adoption as smooth as possible. I've been a code contributor on chef projects during all this time and worked on the Kitchen vCenter driver, several projects related to Train, and have been deeply involved in Chef Infra's target mode. In addition to working with chef products, I'm also very active on AWS and am one of their global ambassadors and community builders. During my talk, we will see how it is now possible to combine those two areas and bring Chef Infra to a whole new level. As with every good TV show, we will first have a look back onto the work which has been done to connect AWS and Chef in the past. Then we will have a look at the brand new support for managing REST APIs with Chef 18, and then look at a promising candidate, the AWS Cloud Control API. I will then take you through my odyssey on making this happen, show you where to find the results, and give an outlook on what we could do additionally. We as chef practitioners are familiar with infrastructure as code. We write code, put it in version control, and can repeatedly create identical environments and correct any configuration drift. But infrastructure as code has several dimensions, not only what we do with Chef Infra or Habitat. First, there's ad hoc executions and workflows. These are single commands or short scripts which get triggered to complete a certain task. Commonly, this involves tools like Jenkins or some scripting with SSH. In the past, Chef had a feature called push jobs for this, but it has been deprecated a long time ago. Secondly, our home territory, configuration of operating systems and applications. This is the area where we thrive, securing systems, delivering applications, making sure the configuration is kept in a desired state. And then, thirdly, something you could call orchestration, creating multiple, sometimes loosely coupled resources and connect them. In my projects, I use tools like Terraform, CloudFormation, or CDK to set up virtual networks on AWS, deploy multiple machines into them, and configure things like security groups as AWS level firewalls. Wouldn't it be interesting to use Chef Infra to do this as well? Not only configure the inside of a virtual machine, but also initiate the creation of it and making sure all or related AWS settings are in a predefined state? And surprise, this already has been possible in the past with Chef Provisioning. It offered a whole ecosystem of backend systems to provision resources to, not only AWS, but also Docker-based infrastructure, Microsoft Azure, and VMware products. As you could see, you could have additional Chef resources which mapped to the cloud provider's definitions. And it was possible to use references between different resources and configure all the properties on these resources. But as you probably noticed, this is all in past tense. This package has been end of life since 2019 and sadly is no longer usable. So why did this happen? It all boils down to two words: manual effort. As the Chef provisioning packages were not generated from provider resources but manually managed, this included a lot of challenges. Cloud provider APIs move fast, really fast. You constantly have to adjust your code to their changes and suddenly appearing new features. Additionally, some APIs are quite inconsistent. If you look at AWS, every service has its own way of doing things. Sometimes you get a list of resources by a function starting with list, but in other times you have to use something starting with describe. Options and terms vary, so you would have to adjust this all the time. And as a result, this needed lots of manpower and did not scale well. And that was the end for Chef provisioning. So how would we solve this? Ideally through automation, but we would need well-defined APIs which have a standardized structure. And this is where we arrive at REST APIs. If we look at these from our mindset of desired state, they are very similar to it. Resources have a specific identifier. In this case, it's usually a path which includes a specific resource ID. With Chef Infra resources, this would be our resource name, right? So just that we do not specify a file to be created, but an API resource instead. Next, these APIs offer different ways of accessing a resource. We can retrieve the current state of it, we can create new ones, change existing ones, or delete them. This is done via HTTP verbs, which specify our intent. And every resource had a list of properties, or in API terms, a list of fields. They specify the details of the resource, readable names, configuration, and so on. This is how the world would look like if it was perfect. We will shortly see it's not in the case with AWS, but it should have similarities. First, we can retrieve the current state of an AWS resource, in this case a VPC. It has a unique identifier and properties like a specific networking range and assigned tags. When we now want to change one of these tags, we can issue a patch command and only specify the changed properties. So if you ever wrote a custom Chef Infra resource, you will notice that this is basically the same thing. Getting the current state would be in load current resource, and changing specific properties would be in the converge by block. I would say this looks promising. So after we covered previous implementation and the idea on how to solve these issues, we need to cover the how. 4 things are vital to make this work. Target mode, which lets you execute provisioning commands for systems without an agent, like an API. Then the credentials file, which is used to specify those endpoints and how to access them. As you might know, InSpec is actually agentless. So it includes a generic transport framework called Train. And it is also the base for target mode, remote OHI data collection, and to a degree, the knife bootstrap command. And lastly, we need a specialized Train plugin, which deals with the generic parts of REST APIs. So, step 1. Connect to the remote system or API. Target mode has been an experimental part of Chef Infra since version 16, but it is still limited. By default, it only enables a few Chef Infra resources for remote execution, basically all those which run shell commands anyway. As a consequence, you need to write your own resources to use target mode. On the flip side, you can now execute Chef Infra against systems via SSH. No remote Ruby or Chef client installation required. The syntax for these runs is pretty simple. The -z means to run without the Chef server connectivity. You could also skip this and make the remote system a full node in your Chef Automate, by the way, if you wanted. -t references the name of the remote system, and then you specify which recipes should be run. So, as we did not supply any additional things on how to connect to the remote system, we need to add these in another place, the so-called Chef credentials file. You can use a lot of different transport plugins. Train bundles the common ones like SSH, WinRM, or even local command execution. But you can install and use more exotic ones like execution via AWS Systems Manager, Telnet, or even serial and USB ports. Every remote endpoint gets the name of the transport protocol assigned, and then the plugin-specific settings. For SSH, this is classically a host, a user, and an SSH private key. As we're talking about REST APIs and not SSH, we will need to use train REST as our transport. This is not a classical operating system endpoint, so we cannot use any shell commands. Instead, we have to access the HTTP verbs we talked about: get, post, put, patch, and delete. The logic of train REST will also do API-level authentication for you. It supports a lot of different ways to authenticate, but for our case, we will use AWS signatures in version 4 and a specific API endpoint on their side. Every API is different, so you need to write some custom code. Usually it's not too much if the API is cleanly specified. The only mandatory part is to add a small OI plugin to tell Chef that this is really talking to AWS and not some different API. In addition, you can include specific behaviors of the API, as everyone has a slightly different way of returning errors, structuring data, doing paging, and so on. Note that we use something new for Chef 18 here, a resource partial. This feature has been part of Chef for a while, but not widely documented. It allows you to create snippets of code and reuse them in your current resources. This way, you can have common utility functions included in all of your custom resources without dealing with complicated object-oriented programming. Chef 18 now includes a new REST resource partial in its core, which already includes standardized implementation to map our load current resource and converge by to the characteristics of REST. This is all generic, but how do we write a specific VPC resource now? Well, Chef 18 also includes extensions to the DSL you use for custom resources. By including the REST resource partial earlier, or in this case in our own partial, it will automatically add those DSL methods. You can see them in action here, defining the path to get a list of existing VPC resources or how to manage a specific one. It also allows you to map Chef properties to JSON fields in different ways. Notice that you have to specify target mode equals true and the remote platform for this to work. And about this specific AWS endpoint we configured early in the credentials file, this is a Cloud Control API. AWS noticed that there are a high number of services and consistency problems are a problem to many software vendors. So in 2021, they added an alternative way to the services APIs and called it Cloud Control API. It solves the problems by offering a consistent API with get, post, patch, and delete verbs and JSON data. On top, it is also possible to retrieve complete type specifications, so you can query which fields a resource expects, which data types are needed, and even get descriptions for them. The API is not perfect yet, it only supports 540 resources, but it's under active development and gets periodically extended. With all that, we should be able to authorize and get a specific resource, but we don't. So what's wrong? Actually, Cloud Control API has its own challenges, which drove me nuts, to be honest. First, they do not use URLs to reference resources, but rather include a specific type name and identifier field in the requests. Secondly, they do not use HTTP verbs at all. Instead, you have to specify a proprietary header. Could have all been so easy, right? But for this API, it just meant that I had to write some wrapping logic, which is generic to the API itself, not for any of the resources. I will spare you the details. It was fun to make this happen. Until now, I skipped one important detail concerning REST APIs. They usually create a unique ID for the resources you create. If you think back at the VPC example, I configured a resource VPC 1234 and so on. But we would not know the ID of the resource before creating it. And REST APIs usually only allow managing existing resources by ID later on. We can make use of the structure of REST APIs here, as they will commonly have one specific field to report an ID. So if we create a VPC, we can retrieve the resulting unique ID for it after creation and save this on the Chef infra server, for example. Later access to the resource can look up that ID then and insert it into the requests. Now, the real fun part. I earlier said that AWS currently includes over 500 resources in their new API, which get adjusted and extended all the time. As we can request a list of the supported resources and all their specifications, we can indeed write a generator. And I did exactly that. It is a Ruby gem which allows generating the complete Chef resource definition of a specific or even all supported AWS resources. And as this changes regularly, I set up a GitHub workflow which runs daily. This will only adjust the resources and properties which change during the day and, if applicable, automatically bump the resource pack version number. Now let's see how all of this works in practice. First, we need to find the AWS provided descriptions of resources. Currently, I do not include Chef-specific documentation in my GitHub repositories, so we have to check on the AWS documentation pages. The information is easy to find if you know how. Let's just open Google and type CloudFormation AWS resource types. I know it's the first match, so I go with the I'm feeling lucky method. We end up on the documentation pages of CloudFormation, which also is responsible for the type registry. You can see the long list of all supported services. For the demo, we will set up some basic networking, which is part of EC2. So in the list of EC2 resources, we choose the VPC, which will be mapped to the AWS EC2 VPC Chef resource. We get to the detailed information, including an overview of its syntax. All resources you see here are also exposed in Chef. Each of the resources has additional information, such as the description, information, and expected parameters. We also find examples. Personally, I find the YAML one most readable. We do not only want to create a plain VPC, but also 2 subnets to make it usable. You can find the corresponding information on the AWS EC2 subnet page. Again, we get the same format of syntax, properties, and examples. But here you notice something else, a specific type of reference function. We will come back to this and AWS region selection when we write the recipe. So let's hop into VS Code and translate our knowledge into a workable Chef recipe. We start with the AWS EC2 VPC resource and give it a sensible name, let's say staging VPC. We learned about the CIDR block property, which specifies our network range. We will pick an uncommon but valid one to keep things entertaining. Next, we add 2 properties related to DNS resolution. This is more to show that everything works. It really is not rocket science. I suppose you also enjoy VS Code proposed snippets, right? Next, we add subnets for 2 availability zones, starting with AZA. AWS EC2 subnet public-A. We will talk about referencing the VPC ID later on. Then we add a CIDR range for this subnet. And we will also talk about the right way to set the AZ name later on. To make things kind of usable, although not recommended, we add automatic assignment of public IPs. Now, let's talk about the AZ name first. The AWS Platform Support Pack includes a helper AWS region, which will include the current region. So we can just use this and the AZ name to get the right value. Here, this will result in EU Central 1A. Next, our VPC reference. I told you that every REST resource has a unique ID. And the new helper for this is called REST ID. We specify the Chef resource as a string, including its ID. Sadly, we need to add this into a lazy block or things will run before the VPC is even created. This just pushes back the lookup to a time when we have its unique ID. Now let's copy the whole thing for our second AZ. Just change the name of the AZ so A becomes B. And of course, we need a different CIDR range. Another fix of the AZ name in the last line. And speaking of fixes, we need to add the missing square bracket. Oops. So that's it, our recipe to create a VPC and add 2 subnets to it. You might notice that I'm using dev containers. If you never heard of this excellent feature, check it out. It provides a containerized environment and all settings are just some files inside your repository. Due to the setup, we can open a terminal window and are inside an environment where Chef Client 18 is pre-installed. During preparations, I added a client config and certificate for a new virtual node and to also connect it to AWS, a credentials file. There is no authentication info because it will be pulled from the environment. You could hardcode some access key if you want though. For authenticating, I use the tool AWSome and hide my secret key like a responsible person. Okay, we are all set up to run Chef with our virtual Chef node, which represents some AWS infrastructure. Chef client, referencing the cookbook I use for this demo, and which I uploaded to the server in preparation. Then the name of our target, so the proper information gets pulled from the credential file. And the client configuration needs to be specified as well. So there we go. Chef Infra client starts running and will include some warning messages about target mode. And it is creating the resources one by one. VPC first. Then the first subnet. After that, the second one. Now we run it again to show it really does desired state. And we can see it's all up to date. So let's check in the AWS console. Previously, there was only the default VPC, but if you reload, we see our new Chef managed one. And the same goes for the new subnets, which are associated with the VPC. Inside Chef Manage, yes, it's outdated, but a quick way to show this, we see our staging VPC node. Its run list consists of the awesome Chef demo cookbook. And under attributes, we see the platform as AWS and some additional info under the AWS tree. To keep track of how REST resources and Chef resources are connected, there's also a tree called REST mappings. Under the name of the cookbook, we see some resources and their associated mappings. Okay, let's wrap this talk up. You can find both the AWS Platform Support Pack with the Chef resources and the generator on these GitHub repositories. Please check them out, and if you find any bugs or have ideas on how to make things better, open an issue. I'm really looking forward to your input. The solution is not perfect in some aspects. First, AWS needs to add more resources. When recording this talk, it was not even able to create EC2 instances. On the other hand, the whole network structure is supported already, so this will be a bit of a waiting game for the AWS API to expand. And for time reasons, I focused on making it work and not super pretty. So my future work will involve also generating the documentation pages for resulting resources and make everything more robust by adding tests to it. But the approach does scale. As we manage hundreds of AWS resources, we can do that with other APIs as well. Many APIs are much more straightforward, even documented in the Open API standard. And I already checked that the information inside of those definitions is enough to generate Chef Infra resources as well. So in the end, there could be automatically generated and updated resources for basically anything with an Open API specification. Things are still not optimal on the REST DSL. With some work, this could be better integrated into the general workflow. As an example, you currently have to specify how to map API and Chef in a centralized statement called REST DSL mappings. Instead, I would prefer just adding an option to the Chef property definitions themselves. And lastly, if we finally got proper YAML syntax for recipes, including helpers and such, we could also use its integrated support for deeply nested type definitions. As I experienced, some resources can have 3 or even 4 levels of nested options. In Chef DSL, this isn't pretty. In YAML, it would be pretty straightforward. If you want to know more about the basics of REST support in Chef Infra, how it is implemented and which areas are problematic, you can also find my video about this on last year's Chef Automate for Good hackathon, either on devpost.to or on my private YouTube. So that's it. I hope you enjoyed my deep dive into Chef 18 and how to connect it to AWS. I'm looking forward to your feedback, ideas, and whatever comes next for Chef Target Mode. Thank you.